Come to Get Smart Stanford. Greetings and welcome to Get Smart with Stanford once again. This video is meant for the grade 10s and we are going to deal with simplification and factorization. So let us see what it has in store for us. If we can learn how to simplify, we just do the basics and understand what it means to factorize. So we are going to factorize and simplify. So in the first question, we are required to factorize. Let us see what we are going to factorize here. We've got 4x minus x cubed. X cubed or x to the power 3 or x to exponent 3. Whichever way you want to say. Okay, let's look into this. For us to factorize, we need to first check what we have. We've got two terms, term number 1 and term number 2, and in between we've got a minus sign. All right. So what do we do? What do you see here? On both terms, there is something which is common, and that is x on both sides. We've got x on both sides. So if we can take out the x as a common factor, let us factor out the x, and inside here we'll be left with 4 minus x to the power 2 or x squared. When you factorize, to show that your factorization is correct, you need to get the original equation when you multiply out. In this case, you would have to multiply x times 4. It will give you 4x. X times x squared would give you x to the power 3. How does x times x squared give you x to the power 3? Let's look into it just a little bit on the side. If we have x times x squared, how does this give us x to the power 3? If you can check your rules of exponents or your laws of exponents, there's a video that I've created titled Mastering the Laws of Exponents. It's for grade 10 also. So let's go and check that one and see how we can best learn about the exponents. So in this case, we are going to write one base. Why are we writing one base? Because these two bases are the same. So if the bases are the same and are multiplying each other, then we are allowed to write one base and add the exponent. You'll remember that this is to the power 1. If it's not written, then you know that it's to the power 1. Then we'll say 1 plus 3. And this is x. Oh, I mean 1 plus 2, not plus 3. 1 plus 2. This is the 2 we're talking about. Then you got x to the power 3. So if you have x to the power 3 in that way, then you know that it's taking you back to the original equation, this one. Then we are sorted. So what is the next step that we need to do when we see this? By looking at this, I see a difference of 2 squares. Difference of 2 squares. Okay, it says here it's difference of 2 squares. Where is the difference? I see the difference here because when you are subtracting, you get the difference. Where is 1 square? I see 1 square, but here it says difference of 2 squares. Where's the other square? We don't see it. we just say it's the difference of 2 squared. But we need to know where the 2 squares are coming from. So if you look at this, at 4, 4 can be expressed as 2 to the power 2. So if it's 2 to the power 2, that basically means we have x into 2 to the power 2, which is 4, minus x squared. Then now we have 1 square and 2 squares. We have 2 squares and we have the minus sign, which it gives us the difference. So now we can boldly say that we've got the difference of 2 squares. If you got 2 squares, then the next step, which would be the final one, would be to factorize or factor out. Then we've got x into 2 minus x, open brackets, and 2 plus x. How can we be sure that these factors are correct? We already have the x, we know where it's coming from, that's fine. But now, in order for us to understand whether these factors are correct, we need to multiply out, and it should give us the terms that we have in the previous step. So we are going to multiply like this. We will have it like this. If you multiply this out, you need to get this. If you don't get that, then it means your factors are incorrect. So I give you a homework to multiply that out and get that. If you don't get what's in the previous step, then something is not right. We also need to remember to put the equal sign there as the steps unfold. Okay. All right. Now we are done. We have factorized, and this is what is required of us. They did not say solve for x, so you don't need to go all the way and solve for x. They said factorize. So now let us see the second one, what we are required to factorize. Number 2, we have x squared plus 15x minus 54. Here we also need to factorize, and this is so simple. How simple is this? For us to factorize, we need to get factors that when we multiply are going to give us negative 54, but when we add them, we must find positive 15x. So let us find the factors of 54 that will suit that. So we've got 54 multiplied by 1. 54 multiplied by 1, of course, if we put a negative here, it's going to give us minus 54. But when we add, minus 54 plus 1 is going to give us minus 53. And if we can put the negative this side, then 54 minus 1 is going to give us positive 53. So we rule this one out. It's not part of it. It's not going to work. Then the second one, we have 27 times 2. Okay, 27 times 2 can give us 54, because if we put a negative here, minus 27 times 2 is going to give us minus 54. But if we say minus 27 plus 2, it's going to give us minus 25. And if we put a negative this side and say 27 minus 2 is going to give us positive 25. So this one also we're going to rule out. We also have another factor, which is if you multiply 18 by 3, we of course are going to get 54. But now let's add and see. If we add 3 to minus 18, we are going to get minus 15, which is incorrect. So let's put the positive here and the negative on the other side. 18 minus 3 is positive 15. 18 times minus 3 is negative 54. Then these factors are correct and they suit this equation. We can factorize using them. There are other factors which you can look at, but they are not going to work. 6 times 9. 6 times 9 equals 54, but when you add the 2, no, you can't get 54 if you can't get positive 15 if you were to put negative here. Of course you would get minus 54, but 9 minus 6 equals 3, and if we put a positive here and a negative here, 6 minus 9 equals minus 3, so it's not going to work also. So these are the 4 factors of 54, but only this one is allowing us to work with. Then what are we going to do? The next step, we're just going to open our brackets, x and x here. Don't forget the equal sign. So we said positive 18, not 8 but 18. Let me try to write neatly. Positive 18 and minus 3. These are the factors that are required, and here we are done. Nothing more is required from you. So now let us put another divider and see if it's going to allow us to work. Okay, fine. Number 3, we've got y minus xy plus x minus 1. To factorize this one, let us first check the first 2 terms here. We've got something that is common there in the first 2 terms. What is that? We have y. Y is common. So let us take out the common factor y. We take out the common factor y. What are we going to be left with? Here we'll be left with 1 minus x. The plus is still there. We just drop it down. X minus 1. Okay. And what's the next step that we need to do here? By the look of things, we are going to get stuck here. But if we look into this, here we've got 1 minus x, here we've got x minus 1. Can't we change one of these two to look like the other without changing the essence of the original equation? Yes, we can. Let us just take this one and work with it here to see if it can give us something. Say we've got x minus 1. If we can take out a common factor of minus 1, then inside here we'll be left with minus x, and this one will change to be plus 1. How so? How can this be true? Let us multiply out and see if it's going to give us that original one, x minus 1. If we take this minus 1 times minus x, we get positive x. Minus 1 times 1, we get minus 1. And this is the same as this. So if it's the same like that, then it means we can be allowed to take out a common factor in that way. But now we know that minus 1 multiplying anything is just that, whatever that is being multiplied by 1. Of course, it will inherit the negative sign. So here we're just going to write negative open the brackets. Can we now swap this like this? Yes, we can. I'll give you a short example of this. We can have 1 minus x. Why can we swap this without changing the essence of its originality? That's because 3 plus 1, for example, equals 4. And 1 plus 3 equals 4. So we just changed the positions, but we did not change the essence at all. So now that we've got this, then we can take this and bring it back to our equation where we are working. We still have the y outside the brackets, and we've got 1 minus x, and now we are bringing down minus into 1 minus x. Okay, so now again we've got two terms. We've got two terms. This is term number 1, and term number 2, and something is common here. We've got 1 minus x, and here also we've got 1 minus x. So what happens from here? What do? We take out the common factor of 1 minus x. 1 minus x. What are we left with in the first term? We are left with y, and the negative is still there. And in the second term, we are left with 1. So this is it. We are done. If you have watched this video to this far, that means there's something that you are liking, and please subscribe to this YouTube channel, Get Smart with Stanford, and also follow us on TikTok, follow us on Facebook. We are Get Smart with Stanford on all those social media platforms. And good luck with your grade 10 exams and everything that you'll be doing in your future. Okay, so I think we are done factorizing. So we continue to the next questions, the next set of questions, which is now going to be our question 2. So our question 2 require us to simplify. Let us go and simplify and see how simple mathematics can be when we practice every day. Of course, you need to practice every day. Ask your teachers some questions where you don't understand. Ask your peers, and help each other. So trust me, you are going to pass with flying colors. And if you know something, make sure that you explain to your peers or your classmates so that you can get to learn more. So here we are going to, okay, let us erase this one because we are now in question 2, and question 2 says we simplify. How then do we simplify, or what are we simplifying? Number 1, we are going to simplify, or maybe because this is a different question, let us use color blue. I love color blue. We are going to simplify x plus 2 into x squared minus x plus 3. How can we simplify this? I've shown you how we can multiply out when we had two brackets multiplying each other and with just two terms per bracket. But now we've got two terms in the first bracket and three terms in the second bracket. What this means is that this x is going to multiply out in the second bracket, multiply the first term, multiply the second term, and multiply the third term. And also this second term, which is 2, is going to multiply the first term in the second bracket, and the second term in the second bracket, and the third term in the second bracket. Let us try and do that and see what it's going to give us. X times x, I've shown you how that works. We're going to have x to the power 3. X times minus x, we're going to have minus x squared. X times 3, we're going to have positive 3x. And then we go to the second term, 2 times x squared, we're going to have positive 2x squared. 2 times minus x, we're going to have minus 2x. 2 times 3, we're going to have positive 6. All right, this is so nice. It looks nice. Now we're going to group the like terms. We've got x cubed and there's no other x cubed in this expression. So we're just going to write x cubed as it is. We've got x squared. There's minus x squared here, and there's positive 2x squared here. 2x squared minus x squared, that is going to give us positive x squared. And we've got another set of like terms, 3x minus 2x. 3x minus 2x is just positive x, and 6 is a constant which doesn't have a friend, cannot be grouped with anything, so it's just positive 6. This is how far we can simplify this kind of an expression, and we are done. So let us go to the next one and see how we can simplify that. Here we've got 5 divided by x plus 3 minus 3 divided by 2 minus x. Okay, let's look at it. So when I look at this, on the left side here I see x plus 3, and on the right side, the denominator, I see 2 minus x. And it would be best for us to write this and make them more similar. If they are both starting with the constant, they start with a constant. If they are both starting with a variable, they start with a variable. So now let's try to make them start with a variable. Let us go and take this one and bring it here, work on it and see what it can give us. Okay, this is 2 minus x. I've shown you in the previous examples how to take out the common factor. So let us apply the same here. We're going to take the common factor of minus 1, and inside we'll be left with minus 2 and plus x. So if we've got this, to make sure that we have taken out the right common factor, we need to multiply out and check. This is not a necessary step in your exam or your test. You don't even need to show this, but just for you to understand where this is coming from and where it's going, we just need to multiply out here. Minus 2 minus 1 times minus 2, we're going to have positive 2, and minus 1 times positive x, we're going to have minus x. And this is the same as this, meaning we didn't mess up with the equation, we didn't mess up with the original one, so we are still on track. And we can simply say minus into x minus 2. Then now we have this written in a similar form as this one. So what do we do now? We just take it and bring it down here, and see what it's got for us. We got 5 divided by x plus 3 minus 3 divided by negative x minus 2. Now we are multiplying negative by negative, and it's going to give us a positive. So we will have a positive here instead of the negative that we had initially. All right. If you need more clarification or understanding about this, feel free to contact me on the number that I will share with you at the end of this video. So right now we've got this, and we need to get the lowest common denominator. Let's say, for example, we had something like 1 over x plus 1 over y. Our lowest common denominator will just multiply out the two denominators and have x, y underneath. So we're going to apply the same method on to this one. Then what are we going to have? Yeah, we're going to have 3. No, it's not. It's I beg your pardon on that one. It's x plus 3 into x minus 2. So that is our lowest common denominator. Then 3x plus 3 times x minus 2 divided by these x plus 3. These ones are going to cancel, and we're going to be left with x minus 2 times 5. Then we have 5 times x minus 2 plus, we do the same on the other side. We're going to have the x minus 2 cancelling out, and we'll be left with 3 into x plus 3. Let us go and finish this on the other side from the top there. Then here we will multiply out these terms. We will multiply out 5 times x and then 5 times minus 2. That's going to give us 5x minus 10. And on the right hand side, we also going to multiply out the 3. We multiply the two terms that are inside, and we're going to have sorry, let's continue with the blue. We're going to have plus 3x plus 9 divided by the same. And we group the like terms on the numerator. 5x plus 3x, that's 8x. Minus 10 plus 9, that's minus 1. Yeah, it's minus 1 divided by there's nothing much that we can do onto this one. So that's it. That's the final step that we can have. We have simplified the best way we know how. So let's go to the third one. The third one says 25 to the power negative x multiplied by 15 to the power x plus 1 divided by 3 to the power x times 5 to the power negative x. Here we've got 25, we've got 15, we've got 3, we've got 5. So for us to simplify this, I would suggest that we try to reduce them into same or similar bases. 25 can be expressed the same as 5 squared. My squared is not very visible. 5 squared, and on top there it finds the minus x. They are going to multiply each other out. And 15 can be expressed as 3 times 5, and they still all share the exponent because they were a one digit and now multiplying each other. That means they still need to continue sharing the same exponent. And at the bottom there on the denominator, let us not change anything for now. Let us use the side on the top, right? So the first term, 5 to the power 2 times negative x, we're going to multiply that exponent, and we're going to have minus 2x multiplied by, we know that, let us first do this. Let's do it right here. If we've got x, y in brackets to the power 3, they need to share the same exponent. That means we'll have x to the power 3, y to the power 3. So we're going to apply that. We are applying that method here. If we can apply it on that one, that means we're going to have 3 to the exponent x plus 1 times 5 to the exponent x plus 1. We divide by 3 to the power x times 5 to the power minus x. All right. Now, if you look at this, we only have two bases, which is 5 and 3. And when we are multiplying the same base, we can add the exponents. So let us add the exponents and see. We have 5 to the power minus 2x. We add x, we add 1. That is coming from this. And we are multiplying by 3 to the power x plus 1. We divide by, we divide by the same 3 to the power x times 5 to the power minus x. Okay. On the numerator, we have like terms minus, let us write the base, minus 2 plus x. That's going to give us minus x plus 1. But now remember, let us come to this side again here. If you have the same base, x to the exponent 2 over x to the exponent 1, this is the same as you write the same base and then you subtract the exponents. When you are dividing, you subtract the exponents. When you are multiplying, you add the exponents. So here would have 2 minus 1, and this would be x to the power 1. So let us go and apply the same on our work. We've got 5 on the numerator and 5 on the denominator. So we are going to write the same base and subtract the exponent. This is minus into minus x. And we can do the same with 3. We've got the same base. We subtract the exponent of the denominator. So now this one, we've got 5 minus to the power minus x plus 1. Negative times negative x, we've got plus x. And here we've got 3. X minus x is 0. Then we have 1. Then on the first one here, we've got 5 to the power minus x plus x. That is 5 to the power minus x plus x is 0. then we're only left with 1, and on the other side we're multiplying by 3 to the power 1. So that is 5 times 3, which is 15. That's it. We have done what was required of us on that one. Okay, we've got another question. We've got let's just erase all these things. Erase all these things. Let me just continue to erase all these things. If you have watched this video to this far, please subscribe to this channel and share it with your peers. Share it with anyone who would need this kind of assistance. Then we are able to help each other. So we've got another question here. It says, okay, let us check what it's required. It requires of us. It says, oh, my pen is getting lost. All right, we're back. It say determine. Let me erase this one. We'll make another one if there's a need. Determine the value of three p plus q all squared if 9p squared plus q squared equals 12, and pq equals minus 3. Okay, we are required to determine the value of three p plus q all squared. Remember, when we've got x squared, this is the same as x times x. When we've got x plus 1 squared, this is the same as x plus 1, x plus 1. So let us go and apply this into the equation that has been given to us. We will have 3p plus q into 3p plus q. I've shown you how to multiply out when we've got something like this. Then 3p, we multiply this 3p, we multiply these two terms, and q will also multiply these two terms. So let us do just that and see where it gets us. 3p times 3p, that is 9p squared. 3p times q, that is 3pq, and q times 3p is the same, 3pq, and q times q is q squared. So let us group the like terms. 9p squared. There's no other p squared, but let us put it next to q squared because they both have squared, even though they are not big friends as such. 3pq plus 3pq, that is positive 6pq. But we have been told here that 9p squared plus q squared equals 12. So wherever we find 9p squared plus q squared, we are going to substitute that by 12. And we've been told also that pq equals minus 3. So wherever we find pq, we put minus 3. Then we have 12. What is 6 times minus 3? It's minus 18. So 12 minus 18, what do we get there? 12 minus 18 equals minus 6. So we have simplified, and that's all that was required of us to do. We have determined the value of 3p plus q all squared as we've been required. If you see just how simple this is, mathematics can be simple, fun, and nice. It's so intriguing to be doing mathematics with the greatest levels of understanding.